Welcome to the session. Greeting of the day. In today's class, we are going to see about some other type of welding operations. Previously, we have seen about these types of welding processes with respect to heat sources, such as gas welding, arc, electric arc, resistance heating, mechanical energy processes like explosive friction, forgings, and chemical reactions of thermal welding process, and other radiant energy process of electron beam and laser beam process. In continuous with this, we are going to see some other welding processes, other joining processes we are going to see, such as brazing and soldering. So this also comes under our melting categories in accordance with that of melting only the filler material. Nowhere we are going to affect the base material. We are going to warmer, but there is no melting occurred on the base material. Only these things of melting of filler metal only occur. How I can able to differentiate these things? The temperature in the brazing will be greater than that of 450 degrees centigrade, and similarly for the soldering, the entire process completes only we are going to melt the filler material. So filler material to be melted, for that how much I am giving the input of heat temperature is less than 450. So this is a simple understanding. So here and now we have done in the arc welding process, we have gone up to melting point 1500 of the materials, and then the solid state welding methods we have went up to plastically deformable conditions around 1200, and we are coming down for the low level of less than 500. What we can do for soldering of electronic components, all chipsets, the green boards, all are done in this soldering we have seen at our homes also. So that all happens less than 450 degrees centigrade, and similarly only filler melting and welding with the base material which is greater than that of 450, melting of filler material happened there. So brazing and soldering, a simple comparison. Greater than 450 is brazing, less than 450 is soldering, melting of filler metal only. Now we come to the brazing and soldering efforts, one of the other type of welding. The metallic components are joined through the fusions or recrystallized of the base material by applying heat, pressure, or both. In brazing, where only the filler metal melts the same point at what we have told in the first slide. Filler metal melts during the process. So in soldering, joining process where the metal are bonded together using a non-ferrous filler wire, a melting which is lower than that of 450 degrees centigrade. 450, this is soldering, 450, less than 450 degrees centigrade. So brazing of the filler metal melting at a point greater than, see, it is greater than 450 degree centigrade. So we should see the procedures. This is how the brazing we are using. For normal, that neutral flame we can use gas flames, but the thing, heat is generated there greater than 450. For joining the gap, not melting the workpiece, only gap is filled. Only we are going to gap is filled, we are supplying the filler wire. See, and the nozzle, flame, neutral flame, and we are supplying the electrode is melted and it is deposited. And then the soldering, you see, less than 450, this electronic board soldering at homes and our mobile shops, we could have seen this. So this process happens, this soldering or brazing. Base metal we are not melting, but the filler metal is melted and it should be go inside and it should be deposited and it should be solidified, the gap to be filled. How this is happened? If the two fairing surfaces and the filler wire are melted, then it can be joint mixing, metallic bonding happens. But here how the welding happens with respect to the terminology of capillary action. See, the flow of liquid when it is drawn into a small space between the wetted surface. So what happens? This filler material after melting, it is getting fluidity to move everywhere, flow everywhere. Therefore, let us consider the lap joint, where we are kept like this. There is a gap between this lower member and upper member. This in between the gap we are going to weld. In case of normal welding process, we will weld this lap joints. But here we are going to use the capillary action method in such a way we are going to melt the filler metal and we are permitting to flow inside the gap between member A and member B. This fluid filler material will go between the gap. Maybe the gap is very minimum, less than 1 mm, less than 0.5 mm, and the fluid goes inside by the capillary actions, and there it solidifies in such a way both member A and member B are joined well. So that is how the capillary actions we are using in the brazing and soldering. So soldering and brazing provide a permanent joint, and the soldering and brazing process lies somewhere in between fusion welding and the solid state welding process. Fusion welding, we are melting both workpiece and filler wire. In solid welding, we are making the not filler material is not used, but semi-solid of base material we are used. But here in the soldering and brazing, one is not at all melted, only filler material is melted. Therefore, just a sentence I am telling, it is a fault between the fusion and the semi-solid plastic deformed condition. It is a separate thing. So the principle of soldering, we enter into number 1, soldering and brazing. So difference of filler material used in case of soldering should have a melting temperature lower than 450. Flux must be applied to the fairing surfaces and then the surfaces are heated. First we are keeping the plate where the filler material we have to keep. The filler material comes near and we are heating through the flame, and the filler material will be melted, dropped down, capillary action, melted, and fills the gap. The welding is completed. Solder is added to the joint and distributes between the closely fitted surfaces. Distribute between closely fitted surfaces. Therefore, and it is solidified. The strength of soldered joint must be less than that of the welded joint and less than that of brazed joints. So here we are getting strength factors less than that of both. The soldered joint having less than strength factors, permanent joint, but strength factors less than that of welding and also less than that of brazing. So these things we should remember. The gap between the sheets, see this line, the gap between the sheet is closely, the gap between these two sheets which we are going to lap joint or which are going to solder, controlled between 0.075 to 0.125 mm. So very minimum gap we have to fix properly, then only this capillary action and then welding will form. If we keep a large gap and we are trying to do soldering process, definitely not possible. So such things we should do, precautions we should do. What soldering then we are using? We understand we are using only filler wire we are going to melt. What is that? We are going to planning the soldering wires. The most commonly used solder is lead and tin alloy containing ranging of 5 to 70% and lead of 5 to 30%. That is why this tin and lead are used as a soldering wires for joining of a soldering compound. Any material, base material, soldering which are possible, we are going for the joining. Tin which contains, you see, tin which contains a melting temperature around 232 degree, and lead contains the melting temperature, TM, melting temperature, which is equal to 327. Both tin and the lead having the temperature less than 450 degrees centigrade. Therefore, what happens? This entire process, we have to melt the filler wire, soldering wire, and then we are going to do the capillary action. So, less than 450, the welding completed. So, this tin and the leads are wire used as a soldering material. So, higher than that of content tin and lowers, melting point of alloy which is done increases the fluidity of the molten material. When it is melted, it is getting fluidity, then it can flow in the gap between this gap between this 0.075 to 0.1. Therefore, it can able to easily. What are the other things we can use instead of tin and lead? We can use copper And zinc also possibility is there, less than 450. See, zinc 420, copper is there, that is a combination of 1080. We are doing the mixing combinations. What are the other we can use? Tin antimony, tin silver, lead silver, tin zinc, all such chances are there. So soldering process, a joining of metal using a filler material of the lower metal point that the parent metal to be joined. So now I am coming to the steps how we can able to do this process. You see, heat both items by applying a soldering iron to the copper and the pad and component lead. First we are making to heat this filler wire which is going to be filled by the capillary action. That we are doing this. So this is the lead tin filler wire, soldering wire we have taken, and this is the soldering gun which is to be heated and deposited. So continue heating and apply a few millimeters of solder, remove the iron and allow the solder joint to cool naturally. What I am doing, I am just like that heating the filler wire and filling the gap wherever it is I needed. Tin lead filler wire I used, soldering wire I used, and the gun filler wire is melted, just like that it is deposited. Simple, less than 450, simple method of heating and melting and filling the gap, permanent joint. So it only takes a second or two to make a perfect joint which should be appear shiny. It's polishingly it will look as a tin and a lead coppers zinc we are using. So for a sketch I can able to tell you, see the base plate of 2 base plates we have taken, and this gap we are going to fill. So this gap I am going to fill here, heating sources, and here this gap I want to fill. This is nothing but a 0.0752.1 mm. So this minimum gap to be heated. First we are generally warming up the plates. So heating the plates first, then warming up the plates. No filler wire is not added, soldering wire is not added there. Then what we are doing? We are adding a small point, you see. This is the soldering wire from the roller, and it is heated. What happens is, due to capillary action, it is slowly getting the fluidity and it flows inside. In this flows inside this gap, and it is pasted, solidified there itself. So 2 base plates which is in the lab jar are welded with respect to simple neutral flame, less than 450. So see, shiny, smooth, soft, a good looking soldering joint. So smooth, shiny, clean and a concave fillet. It forms like this, a concave. Therefore concave is good, convex is bad, and sharp corner should not be there. It will be the stress point, it should not be there. So in soldering also the skill is needed. So for understanding a cold solder wire which having the defect, you see how far it is there, and it is not at all solder. The temperature is not good. The filled soldering wire is not matching with the boards. So such cases will soldering is not happen. So some of the various components I want to describe which for soldering: visors, safety glasses, solder tools, cutters, noise pillars, solder wicks, damp sponges, and soldering irons. Various tools we are using for simple joining soldering less than 450 process. Solder is an alloy of tin and lead. So it is an alloy of tin and lead, that only we have told about 40-60 combinations. And this is the gun which is about maximum of 400 degree, 450 degree centigrade we can able to move over. So tinning process we should do before going for the operation. We have taken the soldering gun and we are doing the tinning process. It means we are coating the gun with the tin and lead soldering wire. In such a way, good conductivity will happen between these 2 soldering wire, soldering gun and the base material. Therefore, before going for the joining process, before going for the soldering treatment, we are doing some tinning treatment on the soldering gun. Then we can able to go for the joining process. This is some preliminary process. So like we untin the zone, And after tinning, you can see some white color, it is coated there. Good conductivity, we will get immediate heat transfer we will achieve here. So the flux is, for we could have to touch the fluxes for those creating fluidities. Chemical component is applied and shields the joint surfaces from the air and prevents the oxide formations. Therefore, we are using this flux. Before allude to the welding operations, soldering operations, you could have seen they have a flux box, soldering wire, they will touch this soldering wire there and they do because heat is generated there. If the heat involves, definitely the atmospheric contaminations, oxidation will happen. To avoid those things, as we have did there in the SMAW process, flux coated to protect from the environment, atmospheric contamination should not happen. The same method we are following here also, we are using the fluxes to provide from the atmospheric oxidation formation. So that is why fluxes are used. But where it will go? There it is in the SMAW process it comes out as a slag. But here it comes out as it is not coming out, it is going to dissolve. It is going to dissolve into the joining itself. It is one of the part, it becomes the part of soldering. So for that is a need of fluxes, it's nothing but a surface contaminations to avoid the oxides, to avoid the oil greases, to avoid the oxidation of the base material, to avoid the oxidation of the filler materials. So to basically it is avoiding the oxidation process both in the filler and the base material. So this is how, see, surface contaminations are there, fluxes comes here and it fills molten fluxes. We are filling the molten fluxes here. After flux filling, we have to do the brazing operations or brazing or soldering operations. See, this is how the capillary action takes place. Fluxes move with respect to fluid. First here, the surfaces are irregular. The workpieces, this is workpieces which are irregular. After applying the fluxes, this becomes smooth surface at the top. Therefore, in the smooth surfaces, this filler material can flow easily. The filler material due to capillary action will flow easily and we can do the welding operations easily. So here one more specimen is there. We are doing the lap joint. So here the filler material is going to fill the gap. This is what the 0.0575 to 0.1 mm gap. So it is flows inside and easily you can able to join. Advantages: a low temperature heat sources can be used, not necessary to melt the base metal. Base metal not melt, that is the important main advantage here. We are not going to melt the base metal in soldering. Part can be disassembled at any time by simple application of heat. The heat is applied to melt the filler material and join. Similarly, when again the heat is applied, again it comes to the low melting temperature and it will get disassembled. It is when the melting temperature is reached, it will melt again. Therefore, at the melting point we can remove. We can disassemble the components. Dissimilar materials can be easily joined aluminium, such as aluminium and bronze and copper to be steel. What is the disadvantage then? We are not getting the strength which is less than, low strength which is less than that of welding and brazing. Less than that of welding and brazing. Damage under high temperature conditions. High temperature we can't able to go because this tin and lip will come over the melting points. Careful removal of fluxes residuals are required. Large sections cannot be joined. So small, it is used for electronic components only. Large sections cannot be joined. Some of the disadvantages are there like this. So the applications. So the soldering is used mainly in the electronics and jewelry metalworks. Some refrigeration components and often assembling and repairing also possible for soldering. But brazing is not like that. Brazing we are going to use the greater than 450. If the temperature increases, we can go for the other higher steel materials. Lowest temperature we have to go for the soldering operations. So there are many terms are there for soldering methods we can do for soldering irons, dip soldering, torch soldering, oven soldering, resistance soldering. Some methods of soldering are there in the soldering operations. So the summary. In welding operations, with with respect to other weldings, other joining methods, we have seen soldering operations and their advantages, disadvantages, applications, and with respect to their working. So what I told you, soldering is less than 450 degree centigrade at tin and lead soldering wires. Most important factors. The remaining part of the subjects we'll see you in the next session. Thank you.